So my name is Maire Duffy and I teach in Clonkeene College in Ireland, and I'm part of a joint project for Science on Stage, and my partner is Nelson Carrera from Portugal. Our project is on radio astronomy in schools, and what we wanted to do is promote the idea of radio astronomy with our senior students who are aged around 16 to 18 studying physics. So we started with making homemade basic optical telescopes, and we discussed the limitations of optical telescopes not being able to be used in the day but only at night time, so that we could bring them on to the idea of the benefits of using radio telescopes. We wanted them to understand radio waves in the classroom, so we investigated radio interference. So we used AM radios, and I also have an electrosmog device that detects radio interference. So if I bring my phone, we can see that there's clearly some interference. So they tried various different electric devices in the classroom, and we also looked at seeing, can we reduce these radio waves using Faraday cages? So by placing the radio in the Faraday cage, it instantly reduces some of those radio waves that are propagating. We then wanted to look at observing this interference. So we used an app such as Firefox or the Spectrum viewer, and by bringing the device near the radio, they could then see where the interference was using their app. So you can see here, this is what an astronomer will do, because they're looking for graphs to see where is that radio waves coming from space. So then we took it to the next level, where they were going to look at these graphs and find more radio frequency waves in their room. So we used a special program, which is an SDR. So we have two types of SDRs. We have this one here, which just is like a USB key and plugs into the laptop. And what you can do then is, when you connect it to the laptop, you can now change the frequency that you're trying to receive and then view the signal. And at the moment we just have noise, but if I take a remote control car and I press and we look, now we can see there is a peak. So we can now detect the frequency. And on the back we can see it's 40 megahertz, and therefore this is why we have at the 40 megahertz. So then we said, let's see, can we find an online program that would allow them to look at radio waves? And we found a program called the Pictor Telescope. And with the Pictor Telescope, it is a radio telescope in Athens, and it's free to educators and students, and it allows you to look and detect the neutral hydrogen line. So when you type in your email, they will send you then the graph of the signal they've seen. And by using Stellarium, the students were then able to see what was in the zenith in the night sky and what were they observing. And they can also check then, has it been blue shifted or red shifted, and then has the galaxy moving away from us or towards us. And then they can use their Doppler formula to calculate the speed of which the galaxy is moving. Then we said we wanted to try and build radio telescopes. So we had 3 radio telescopes to build. So the first one was with a satellite dish, which we got for free on zero waste. And by using a signal finder, they connect a very simple circuit to the satellite dish. And by turning it in the sky, all of a sudden when it's pointing at the sun, they get an increase in the signal. So they can hear that pitch and detect it. So by closing their eyes, they can even find the sun in the sky. The second radio telescope that we began to work on then was a horn antenna. And this was based on the idea that the first detection of the cosmic microwave background radiation was used by using a horn antenna. So this is a scaled down version for travel purposes, but we had a much bigger version in the school. So the students had to calculate the dimensions of the can, where to place the antenna, and also the antenna length to detect the 21 centimetre line. So it had to be a quarter of the wavelength, so 5.25 centimetres. So we hope then to use this to get a drift scan of the sky and hopefully detect the Milky Way. Then Nelson School had been donated a parabolic radio telescope dish, and their mechatronics class then have built this fabulous structure to house the dish on it And by using Arduinos and lots of motors, it can actually then rotate in the night sky to detect it. So we also then looked at where's the best place to place a radio telescope, and we created a Padlet that allowed then the students to map radio telescopes around the world. So we can see the map here. So I didn't tell them which ones to look, they just found it. And of course, if we zoom into Ireland, we can see, well, where is our famous radio telescope in Ireland? It's of course in Birr. We can see there's not a lot around, there's a small town, and of course, this brings it back to the experiment with the radio interference. A great place, and where should we put them? Low noise in the world.